hope you're all having a good evening. Thanks for spending your time with me instead of sitting on the sofa watching Netflix. The idea is we're going to learn something about TIA Portal here. I'm going to show you how to structure a messy application. I'm going to give you some tips. I'm going to give you some guidelines on how you can structure a PLC application like that in TIA Portal, but you can use as well these principles to structure PLC applications for other vendors, for Rockwell, Beckhoff, B&R, etc. An important point is that the structuring principles which I'm going to teach in this course, they are independent of which TIA Portal you're using. So it doesn't matter if you're using TIA Portal 14 or if you're using the very latest TIA Portal 20. So it's independent of the TIA Portal. You can do all these structuring principles and concepts that I'll show you in any version of TIA Portal. And what's as well very important, it's independent of the language that you use, because there's so much talk about which language is the best. I don't get mixed up in those conversations because I don't think it's the most important. Some people like ladder logic, some people like structured text, some people like function block diagrams. Personally, I don't think that's the most important for a PLC programmer. I think structuring your logic, knowing how to make or how to organize your logic, how to make modules is much more important. And that's what makes the difference between a very good programmer and just a default, a standard PLC programmer. And if you're just about to get started with your first TIA Portal project, or you simply want to get better at structuring PLC applications, then don't forget to grab my free guide. You can download the guide by simply clicking on the link in the description below this video. There's no better time than now to start your TIA Portal journey. All right, I'm going to start by showing you the TIA Portal, the Messy program. So I am using TIA Portal version 18 right here. And you can see I have a project opened, which is called Project Molding Line. That is the kind of the sample application that we're going to use today. So I based this Messy program on one of my own programs. Of course, I changed the blocks and everything a little bit, but it's based on a molding line. I'm going to explain you in just a sec, like what a molding line is. But let's have a quick look. So basically, everything is just one big list of blocks. And that's a lot of applications that I get. I receive them like this. So it's just FBs, FCs, DBs, all in one long list. The same, I mean, if you have experience with Semantic Manager, this is how Semantic Manager used to be. There was no possibilities to group anything. But you know, we have evolved since then. But you still see software like this. This would be as well software if you do a migration from Semantic Manager. This is how you would start out. So if you ever do migrations from Semantic Manager to TIA Portal, then this is your starting point. And here at the bottom, we have, again, some things I see all the time. It's a group which is just called module, which doesn't say anything. It doesn't add any information. And if we open it, we can actually see its safety blocks. So calling the group safety would already be a huge improvement. But so this is things this is not like exaggerated. This is things I see in real life. Groups that are called module. A couple of weeks ago, I was on a commissioning and someone thought it was a good idea to call every group module 1, module 2, module 3, module 4, which of course was difficult to figure out what was in the modules. So I had to go in, check out the logic, and I renamed the group and reorganized the software to make it easier to read. And here's another group. These are functions and function blocks for an SQL communication to a SQL database. And this one is from a particular company called SQL for Automation, I believe it's called, which is a Swiss company who makes solutions for connections to SQL databases from Siemens and Rockwell. This is the sample application that we're going to restructure, that we're going to reorganize. As I told you, it's based on a molding line. A molding line is basically a line that uses plastic or metal or wooden or silicon molds together with a conveyor to move those molds. The idea is that you pour a liquid material into the mold. So each mold gets a deposit with a liquid material. Then that liquid material is cooled down in a cooler. And then afterwards, the solid material is being removed from the mold. The solid material is removed from the mold and it then goes further to the packaging, secondary packaging, etc. What we're going to do with this molding line program, we are going to clean up the program blocks. So all the complete list of blocks here, including those interesting groups already made at the bottom. We're going to clean it all up. And the first step that you should always take before you start an application or before you clean up an application is defining the modules of that application. You're going to try and define the modules because afterwards with a modular PLC application, it's going to be easier to maintain that software. It's going to be easier to update that software if the customer wants new features. And it's going to be way easier to troubleshoot that software. So modular programming is what this workshop is all about. And to start with this first step, I'm going to give you a quick overview of which modules are in this example, in this molding line. We're going to start with the process modules. So this is just an example of a molding line where you can see each mold individually drawn with the molds moving forward at the top and moving backwards at the bottom. What I'm going to tell you quickly is which modules you can expect or which modules that we are going to define for this sample application for this molding line. So the first module of this molding line would be the mold conditioning. And the mold conditioning is actually the preparation of the mold. It prepares the mold before we're going to pour the liquid into the mold. So, for example, you would be cleaning the mold to make sure that there's no product left from the previous cycle. You might get the mold up to the right temperature because some molding lines, they require the mold to have a certain temperature in order to pour the liquid into it. Basically, conditioning the mold, getting the mold ready for putting the liquid into the mold. So then logically, the next step is depositing the liquid. So that's the depositing module. And that's where you're actually going to pour the liquid material. It can be soap, it can be a candle, liquid candle, it can be chocolate, it can be epoxy. So that liquid material you're going to pour into the mold into depositing module. And then after you've deposited, you kind of need to settle. You need to make sure that that liquid material goes to all corners of your cavity. If you imagine a mold it can have one cavity or it can have different cavities. You want to make sure that the liquid that's inside those cavities moves to all the corners so that it settles, that it nicely spreads over the surface. That's a settling area. So the next area then is where you're going to actually cool down this liquid material. So you're going to turn the liquid material into a solid product. After the cooling module, you could have an inspection zone. So an inspection module, this is where you check the quality of the product, the consistency of the product. Before they get packaged and distributed, you can have, for example, a vision system, or you can have, for example, a weighing station. Mettler Toledo, for example, makes weighing cells. So you can have a weighing station that checks for the correct weight of a chocolate bar, for example. So that's the inspection zone. And then finally, after the inspection zone, you would have a demold area. And a demolding is actually the process of removing the objects from the mold cavities. So you would get the solid products out of the molds. And you can do that, for example, by using ejector pins, so pins that come out and press the material out, or you can have air blowers that blow the material out of the molds. There's different solutions depending on which industry you're working in. So those are the main modules that actually part of the conveyor. And apart from those main modules, you'll have as well the machines before your production line, which is called the upstream part. And you'll have the machines after your production line, which is called the downstream part. And the upstream, as visualized here, comes before your production line, so before the molding line. Some examples of upstream would be, for example, in soap production, you could be mixing oils. You could be creating a lye solution, which is a solution used in the production of soaps. Water and additives, mixing tanks, that would all be part of the upstream part of a soap production. And for chocolate productions, you could have part of the upstream would be the whole chocolate part, chocolate tanks, tempering machines, which take care of forming stable crystals in your chocolate. So those are all examples of the upstream module of the application. And then afterwards, after your application, after the molding line, you would have the downstream module. And a downstream module can be, for example, a buffer between a molding line and a packaging line, something that temporarily stores products and prevents bottlenecks and improves the workflow. And afterwards, you can then have the primary packaging, the secondary packaging, the labeling, etc. Those are all downstream processes, so processes that occur after the production line, after your production line, your application. Okay, so now that we had an overview, I'm going to go back to our TIA portal application right here. Yeah, as you can see, I put all the modules right here. The top part of my screenshot here are the process modules. So those were the upstream, all the modules of the molding line, and the downstream. And next to the process modules, you have the general modules. These are the modules which apply to your whole machine, to the complete machine. So they are not specific processes on your conveyor, and they are processes like recipe handling, alarm handling, a machine state handler, network diagnostics, PLC status, safety would be part of that, line control. So it's actually modules that are not really specific to this process, but it's like modules that you find on any PLC application. So those I typically distinguish between the process specific modules and general modules. They can be called machine modules as well, or system modules. So those are modules that we are going to reorganize as well in this application. Yeah, so back to the application. So the first thing I want to mention here is, and I've seen this a lot as well, is that the project name and the PLC device name are not taken serious. I mean, if you create a new PLC, the first name the default name would be PLC_1. We're going to start by renaming that. So I'm going to rename this to PLC molding line, which is part of the project molding line right here. PLC_1 doesn't say anything. PLC molding line, on the other hand, lets maybe the programmer that you give the software to afterwards, let him know that this is actually a molding line. I mean, this even gets more important if you have multiple PLCs in one TIA project. It's good to know which PLC stands for which application. That was the first step. And then the second step is we're going to start creating groups for our different program sections. So what I typically do is I make a difference between process-specific modules and the general modules. So we're going to create groups here by right-clicking and saying Add New Group. So I'm going to start with a general group here. So this will have the recipe handling, alarm handling. It will have network diagnostic, etc. So general machine modules which apply to the whole machine. And then I'll make another group for the process modules, so the mold conditioning, the depositing, the cooling, etc. And we'll call that process. I mean, you can call it process modules, you can call it, you can change the name if you want, but I like to keep it short. I think that's short and descriptive. So if I can, I'll try to keep it in one word. Another thing I always do for applications that have safety and motion, like this application, don't mix them up with the other modules. Create a separate group for them and make an interface. Create a clear interface to communicate between your main program. So I'll add those groups here. So a safety group that's going to have all the safety blocks in it, and a motion group. Motion group. That's going to have everything, all the blocks that have to do with motion. And I mean, the reason I like to keep them separate is because sometimes you will have a project and, for example, or you have a client and the client says, we would like the motion to be one type of PLC maybe, or maybe they already have motion, it's running on a back-off PLC, but the standard software, the standard TIA application runs on a TIA PLC. So safety and motion separate groups. Well, TIA Portal organizes the groups alphabetically. So you can see after all the blocks, it starts with general, then that module with the safety in it, motion, other. So it's just a alphabetic order of the groups. And what I typically do to choose my own order of groups is that I add numbers in front of each group. So for example, for the general group, I'll add 110. These are just numbers that I tried out when I was preparing this application. For the process, I'll put 130. So you see automatically now it's placed underneath the general block. For the motion, I'll take 150. And for safety, I'll take 170. There we go. So you see, by using these numbers in front, you automatically order your groups, which comes in very handy. You know, they're not just in a generic order, an alphabetic order, but you can decide which order you want them into. I just saw one block that I forgot. One group that I forgot is for organization blocks. So I'm quickly going to add that as well. And we're going to give that 000 here. Organization blocks. And that goes all the way at the top, as you can see. All right. So those are our main groups: organization blocks, general modules, process modules, motion modules, and safety modules. Now that we have our modules, I'm going to start to move the different blocks into the different groups. I'm still missing two groups, I just noticed, which is two groups I will always have in my application, which is a data group. So 200 data. And I would always have a library group, 300 library. All right, so yeah, the data group I always have because that's where all the global data would be. So everything that is globally used between the different blocks would be under data. And the library, that's where you would have your reusable function blocks, function blocks that could have version control, that can be used multiple places in your application. Those will be placed under a library group. So we got the groups, and then normally what I would do is I will start to move the different blocks to the groups. So let's see, we're going to start with the organization blocks. I'm going to move all the organization blocks under the organization blocks group. The only thing that I like to keep out is the OB1, because the OB1 is the main program cycle. I always like that one to be visible when you open the program blocks. But you know, that's a matter of taste. It's not a must. So I move all these OB1s to the organization blocks folder. Unfortunately, it's a bit of scrolling down. So there we go. There's organization blocks for cycle interrupt, for folds, a startup OB, time interrupt OBs. So they're already nicely organized under this group. Then I'm going to move, because that's right here, I'm going to move all the DBs, so the data blocks. I can easily select them because they are, I mean, most of you have experience in TIA Portal, but you have an icon in front of the DB, which looks like a small container. So it's easy to select them all like this. And then I will drag them to the data folder like this, and I'll close it. Next up, let's see. I think I'm going to start by moving the general function, so the recipe handling, the conveyor, the air supply and stuff like that. I'm going to move that under the general folder. So that would be air supply, alarm handling. Let's see, conveyor is a general module. I'm going to go down the list. Machine states, that's the machine state handler. That's a general module as well. Network, diagnostics, OPC, there's a connection or a block that handles OPC communication. PLC status block, power supply block, recipe, and safety. And finally, I think, yeah, that's the last one. An SQL, SQL database communication. So those blocks I'm going to move to the general folder, general group. Should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 11, so I'm still missing one. Let's see which one. Line control, that's the last one. Yeah. I mean, obviously I prepared this application a little bit, so I know I already know which blocks belong to which groups. But, you know, if this would be your application, you would probably have to go inside the block and check which logic is inside the block before you move them, just to find out what type of lock is it, what is it controlling, is it a recipe handling, is it an alarm handling. So those are the general modules. I'm going to work on those later. So let's have a look what we have left. We have safety blocks. Okay, the safety blocks I'm going to put under the safety group. And I don't know if you remember, but we have this module here which contained the safety blocks. So I think everything apart from these two DBs, this is data as well. So I'm going to put these under the data block. Apart from those two, these are all, yeah, this is a data block as well, but I'll show you in a second. This one is called together with your main safety function. So this one I'm going to put under safety. So all your safety blocks for now are saved under here. I mean, maybe some of them will be library blocks, or maybe some of them will be reusable function blocks, and later on we have to move them to the library. But for now, I'm just putting the blocks where they belong first, and afterwards I'm going to look a bit more specific at how we can reorganize the reusable blocks into the library. This module is empty now, so I can delete it. And then finally, I'm going to put all the other functions right here. For now, I'm going to put them under the library folder. Right there. And we're going to close this because I like to have a nice overview. And these ones, this is SQL communication. I'm going to put, these are going to be library functions as well afterwards. So, excuse me, I'm going to put those under the library block as well. And this one we delete. Okay, so I don't know if you remember the first software we had, where you had a really long list of blocks. So we have reorganized this into 1, 2, 3, 4, 5, 6, 7 groups with, and I always like this, the main OB1 still sticking out. The next step, what I'm going to do is we have all these process modules, as you can see on the screenshot, the upstream, depositing, cooling, settling, etc. I'm going to create groups here under the process group, and we're going to give them numbers as well, so we can put them in the order that we want. So I'll start with the upstream group, and I'll call this 131. So here I've created a system where every number is just going to be used once. I mean, this is just something I figured out for this application. I mean, I tried to do it like that normally to give it like a unique number, but it's not necessary. But I just found a nice way to restructure this one. 132 would be mold conditioning, so I'll just call this conditioning. You can just follow along on the screenshot right here in the workspace. Then we have a group for depositing. There we go. Then the next one will be settling. That's where you will get the liquid out to the different corners of your cavity. 135 cooling. Next group will be inspection. So you can just follow along on the screenshot so you can see that's exactly the modules that we have defined before. Those modules I'm turning into groups into the application right here. 137 demolding, where you get the solid product out of the mold. And then finally, yeah, we can call this 138. The downstream, or, you know, normally I like to give a bit of space, you know, if you would, the downstream is always typically the last group in your module, so we can just call this 149. So in case you have you have more modules, you have lots of space with your numbering to add modules down here, with your downstream 149, which is one number before 150, being your last sub module here under process. That's all of the list. Those modules have been defined. And then what I normally do is that for each module, I will define minimum 2 functions or 2 function blocks. And the first one, I'll take the example for upstream here, as I will create a new block, a function block, which will be the main function block for upstream, FB upstream main. Oh no, we're going to do this as an FC. All right. Yeah, I can give you some more information about it later. I've chosen an FC right here. The difference being that in an FC, you will not have instance DBs for the different function blocks you will call inside. Well, with an FB, you will be able to put all your instance data inside the DB that's going to be called with that main FB. And the second block I would advise you to make in a module is a configuration block. And for this, I typically use a function again, an FC, and I would use SCL for that. I would call FC upstream config. At least those 2 blocks I would have in every module. So I'd have a main module, and in the main module, I would call the different sub-functions for that module. So for example, in upstream, you might have a mixing tank. So under the main function, the main FC, I would call a function block for mixing tank. You might have a TCP communication to that mixing tank would be another function block. So you would have a call for a TCP communication. If you work on a chocolate machine, you might have a call to some chocolate tanks, chocolate control. So all your different function calls, your function blocks that you would call for the upstream module would be all containerized, would be all underneath the main function, the FC upstream main in this case. And for every module, you would just use those 2 functions as a basis. So I'll give a couple examples here. This one would be FC conditioning, config, FC conditioning main, etc. So a configuration for configuring that module and a main block for calling all the different functions which are related to that module. Some people say the configuration you can put outside as well, just one configuration file for the whole process, which means you would have a really long list of configuration data. Personally, I like to have the configuration under the module because this again makes it more modular. So it means if you would have to remove a module, you remove the whole module, including all the function block calls or the calls within the main function, and you would remove the configuration. Else, if you would remove or add a module, you would have to go in another configuration, like under process, and then change that. So I prefer that everything is like containerized and together under one group. And after this, another important step is for each segment, the general segment, the process segment, the motion segment, and the safety segment, I would just have one call, one block call that would call the different modules under that section. So here under the general, we have air supply, alarm conveyor, line control, machine states. Those different blocks need to be called from somewhere. I mean, I'm not going to call them directly in the OB1, but what I'm going to do is I'm going to add a new block. I'm going to move that out of the way of my screenshot like that. And I'm going to call this FC process modules. I'm going to put this in ladder again. This is not a workshop about languages. If you like to do that in SCL, that's fine. I use ladder myself. And then under this process module, I will call the different sub-modules or the different modules of the general, the general group. So I guess you get the idea here. So all these different blocks, all these different modules will be called under the process modules. I will do the same for the process. So I will add a new block, put this to the side so you can follow along, and I will call this FC process modules. There we go. No, yep. And the reason I cannot do that is because I had the wrong name here. So this one is, of course, FC general modules. And this one will be FC process modules. There we go. 2 more to go. For motion, the same. Add a new block. Function FC motion modules. And for safety, I mean, for safety, we already have actually a module call. Let me just have a look where call safety. This is the one, call safety and call safety DB. If you have a look under your safety administration, then you can see here, no, you cannot see here because it's behind. Let me just remove this one. Here you can see that the call safety and call safety DB, that's actually the call of the whole safety program, and that's happening in a cyclic interrupt in OB124. So call safety DB, they are being called here. So I'm just going to rename it to FC safety modules. And this one I'll call IDB, instance data safety modules. There we go. And just to make this nice and a little bit more structured, I'll just put everything else for now under modules, or even better, because this is not so clear. I will do to do so it's very clear that this is not finished. Safety modules, I moved it. All right, so now it's clear that you have here the main call for the safety modules, the main call for the motion modules, the main call for process modules, and the main call for the general modules. And what I'm going to do now is I'm going to call each one of those in my OB1, and that's the only thing that I will call in the OB1. So you see the OB1 has, at the moment, has some calls for air supply, conveyor, machine states. I mean, those calls don't belong here. They belong under the main calls for that specific segment. So they should, the machine states is being called under general modules as a conveyor, power supply as well, network, PLC. I think it's a bit messy to have all those called in the OB1. So I'm going to start by removing all the networks here. And then I'm going to make a call for each module right here. So call general modules, right? And you can see everything, yeah. General modules. So that's the only thing I will call in my OB1. Process modules. Here I'm going to put the motion modules. And as I mentioned before, the safety modules, they're already called in a interrupt OB, so we don't need to call them here. I think they're set to being called every 100 milliseconds. So they're automatically called already. But you see how much more structured the OB1 got. So we just have 3 calls in the OB1, the general modules, the process modules, and the motion modules. And now as well, if you want to move the motion, for example, to a different PLC, you just need to delete this call here, and that's it. Of course, it's not only that you need to make an interface and everything, but by having it separated, it makes it much easier to separate the logic. Okay, I mean, I hope you see the advantage in using such a organized approach like this. I mean, that's the main idea of the process modules right here, the motion modules, the safety modules. What I still like to do, I like to organize the library data, show you how I do that. Let's first create some groups here in the library to get a little bit of more organization, because this is, as you can see, it's still quite a mess. So I'm going to try and use the same numbering here. So I have 110 for general, so for general blocks. So here I'm going to use, so add new block. I'm going to, no, that was wrong, add new group. add new group. I'm going to use 310 for general library blocks. And here we have 130 for process, so 330 for process, 350 for motion, I think, yeah, 150, so I'll use 350 here. 350 motion. Then safety 370, so you can safety 170, so I'll use 370 motion. And then what I would typically have as well is a, if you have different vendor, I mean, these are all user blocks. These are created by the PLC programmer who made this application. But typically you would have as well vendor-specific library blocks, like, let's see, for example, SQL for Siemens. This is not a block that I created or that the programmer created. This is a block created by an external company who made this interface between a TIA portal and a SQL database. Same as these blocks. This, for example, are blocks for weighing cells, Mettler Toledo. These are just blocks provided by Mettler Toledo. So what I typically do, I'll make a group for vendors as well. Add new group, 390 vendors. And here what I can already do is I can, because we just mentioned it, I'll make a group for Mettler Toledo. 2 T's as I can remember, Mettler Toledo. Anyone, please correct me if I'm writing these vendors wrong. Toledo. And then we have SQL for Siemens. There, and I can already put these blocks under the right group. So that's the weighing blocks right there. And then SQL for, here's still another one, SIA. Once again, you don't know this, I guess, up front, right? I mean, but I've worked already with these weighing cells, so I know that these ones are Mettler Toledo blocks. If you would get an application like that, you would need to open the block and see what it's used for, of course. That's the same that I do if I get a new application. I need to go, this is a, let's just say a faster version. Normally you would have to go inside the function blocks. And then I'll move the SQL for Siemens blocks right here. There's one more here. All right, SQL for Siemens. Okay. So these blocks are nicely organized under the vendors group. 370 is safety, you're absolutely right. So that's it for the vendors. Let's see if we can get a little bit more organization here. The general blocks. Okay, let's see what we can first find. Motion, these are motion blocks. So a motion block for torque control, for software hardware limits or position errors. These are reusable function blocks because it's if you have more than one servo drive, if you have 5 servo drives, you will have to call this motion torque block 5 times if you actually have torque enabled in your application. So that's why they belong under the library and not directly under the processes. I saw as well some other here, and a virtual axis, a physical axis. Again, those are multi blocks that can be used different part of your application. I'll put them under motion as well. For safety blocks, let me have a look. I think here under the to-do, there are some safety blocks that are reusable. For example, a guard control, an e-stop control, every time you have a guard, you will call this block, so they can be used more places in your software. All guards, all e-stops, that's probably going to be a summary or a collection of all your e-stops, so that's going to be used only one time. So those ones, an air valve control, that's as well, if you have, different air valves. I'll start with these ones. We'll see if afterwards we need to move some other ones. So these ones go under the safety block of the library. There we go. Let's see what else we got. Weighing station, vision data, that is actually more, that's not something general, that's more related to the inspection. If we have a look here, these would be part of the inspection module of our process. So it's a process, it's under the process library. Profibus status, Profinet, power supply, etc. Those are general blocks. A mold heater, a mold cleaner, that has something to do with the mold conditioning, which is the first module of our process. So that goes under process. We're getting closer here. PID control, cooling control, depositor control. Those would be part of your process as well. It's cooling and depositing. Shaker control would be part of your settling module. VFD control. That's actually, yeah, a VFD control is actually, it can be part of different, it's kind of like a help function. It can be part of a cooling fan, for example. It can be part of a vibration table, uses a frequency converter. So I would typically make a separate folder under the library called help functions. I don't know. I've not come up with a better name for that. But it's basically it's smaller functions that are part of other reusable functions. So you might have a cooling control, a cooling function, and underneath in that cooling you would have nested a VFD control. You would have nested a temperature scaling block, maybe some other ones. So. Let me have a look. So a VFD control would fit as a help function. A small shift register for 64 bits, analog sensor, temperature limits. Those would all be help functions because they can be used they're like smaller functions which can be used in some of the other functions. This is a filter. Again, that's a smaller help function. System flags, a conversion, a real to a time conversion, an element count for arrays, limit checks, element count again. Those would go under help functions. And now we're getting somewhere. Reset alarms. Yeah, that's probably a general function because that has to do with the alarm handling. Cooling, temperature cooling, that's a process. Starting and stopping the line is actually part of the line control, which is a general module, as you can see in the screenshot. Conveyor control, air valve control, that's part of general modules. And you see we're almost through it. SQL, general modules, and horn control is part of the line control, is like typically a beacon with some lights running, a line running faulted, you would have a horn, and that's part of that would be a horn control as well. Okay, so as you see, our list is gone here. We have all organized them or reorganized them under the different groups. And here, as you can see, if you look at the numbering, I mean, it's not always it fits this good, but in this specific example, I've tried to make the numbering as well continue under the library. So the last two digits here, 310, 330, motion 350. So it's all neat and organized. I mean, it's maybe a little bit overkill here. It doesn't need to be exactly those numbers. I don't always hit this target, but it's like I said, it's a matter of taste. I mean, you might have a different system, but I would advise you to use some kind of system that you can create an order in your different groups and that you are the one defining the order and that it's not just randomly defined by the first letter of your group name. So Siemens, please, maybe in a later version, change this. I know in other softwares like in Rockwell, it's possible to organize your different programs as you want, but in Siemens, it's not possible yet. So that was the library. So those will all be reusable blocks. For example, the process folder under the library would have different blocks which you're going to use in the different modules right here. For example, the depositor control is probably a block that you're going to call under the depositing, under the main function, which you're then going to create under depositing. The mold heater would then be part of the conditioning, so you would be calling that in the main function here. Shaker control would be part of the settling group, etc. And as I mentioned, the last thing I'm going to do here is that I'm going to rename the blocks. I'm going to share with you like a method of renaming the function blocks, the functions in this example. You know, that makes everything clean and easier to recognize. Okay, so I mean, the organization blocks, let's start here. I typically don't change those because those names come straight from Siemens when you create them. So, I mean, in some projects, I have called them OB and then tried to make the name better. But yeah, I would say let's leave those ones for now. Those are okay. Those kind of are clear what they are. And then under general, what I'm going to do here is I'm going to, first of all, I never really use all capitals for my names, for my block names, and I don't use underscores. I think it's a little bit old-fashioned, but I mean, again, that's personal taste, but I'll show you how I will rename this block. So air supply, not supply. I will call FB, and then because we're under the general group, general, air supply. Alarm would be FB general alarm. And I will copy this one because that makes it easier. General conveyor. General line control. Machine states, I'll call that state handler. Network. Network diagnostics. OPC communication. PLC status, last four, power supply, recipe, call that recipe handling or just recipe, personal taste, safety. I mean, we have of course the actual safety blocks under the safety group, but this would be some kind of communication between the safety parts of your application and the standard logic of your application. You know, maybe e-stop okay, or guards are open. You have some kind of interface, so you can use, you have a clean cut between the main part and the safety part, so that would be under the safety block. And then you would have an SQL communication. Okay, so I mean, this makes it more clear that each one of these blocks are part of your general group, of your general machine control. And for the process group, we already defined these different functions. Motion, we don't have anything in there yet. The data we're going to do in the next session. And for the library, we can as well rename them a bit better. And since they're part of the library, I can call them FB-lib, for example, or you can write it out long if you want. Alarm reset. And this one is an FC. I mean, you might be asking why I am using FC and FB in front of the blocks when the icon actually shows you which type of block it is. The icon in TIA Portal shows you if it is an FC or an FB. I don't know, it's a personal taste. I just really like still the FB or FC to be there. One advantage is as well that in TIA Portal you have to think about that every block name has to be unique. So if you would leave the FB out, and let's say you would call your FB, you would call it alarm, for example, and then you want to create a DB which you call alarm, then that's not possible because that name is unique. So by using still FC or FB in front, if you then create a DB and you call that DB, then you will not have that conflict. So it will already be a unique name just because you're using the name of the block in the front. This was air valve control, FB air valve control. Yeah, I'm not going to do all of them, but this is just to give you an idea how I would rename those different blocks under the library. Conveyor jog control, conveyor jog. Yeah, I mean, I can give you an example for the motion. This is something that I use sometimes. I would call it library motion, physical axis. Yeah, that was it. Motion, axis physical. Axis virtual. Control position error. Position error, you can write it out long if you want as well. And here hardware control software hardware limits control torque. And then finally I can give some example for safety. So in the same way, can call it every library safety, control air valve, control contactor, control e-stop, and control guards. There we go. So I hope this gives you some kind of idea of how you can actually rename your functions so they are a bit easier to identify. I used the FB lib here to start with to show that they are library functions. I mean, you could go one step further. You can start using the libraries in Siemens and make them version controlled over here. I do that for some of my projects. But one first step, I think, is starting with a library over here. And then the second step is by actually integrating into your libraries. So yeah, I'm not going to do all of them here because I think you're all going to run off then because it's a little bit monotonous. But so for library, FB lib, for the general blocks, FB general. Again, it's not black and white, you know, it depends a little bit as well as the client you're working with. Maybe they have another standard of naming the blocks, but this is something that I typically use for the processes. I use the name of the process module, FC upstream, FC conditioning, so that it's always clear what's inside the block. So what the naming should be not too long, but it should at the same time be clear what's inside, what logic you will find. It should not be guesswork. Now, session 2, as I told you, the goal is to reorganize the data. Let me just close this. So we're going to do that in 3 steps. First, all right, I'll close all of this here. First, we're going to have a look at the PLC tags right here. Then we're going to have a look at the data, which in the previous session we stored right here. So all these DBs we are going to reorganize, and it's going to be very interesting because I'm going to show you how you can make really nice structures within those DBs. And then finally, I'm going to have a look at instance DBs, and especially we're going to have a look at single instance DBs versus multi-instance DBs, and I'll tell you a little bit about when to use which type of DB, when it makes sense to use a multi-instance, when it makes sense to make a single instance. And if you're just about to get started with your first TIA Portal project, or you simply want to get better at structuring PLC applications, then don't forget to grab my free guide. You can download the guide by simply clicking on the link in the description below this video. There's no better time than now to start your TIA Portal journey. So number one, PLC Tags, that's where we're going to start. And right here we have the PLC tags, and as you can see we have just one huge table which is called default tag table. So that's where I would say that's the first mistake. I mean, if you make a new tag table in TIA Portal, for example, right here it's called tag table underscore one. I mean, please start by renaming this tag table into something useful. You can just click on it and press module inspection, for example. I mean, do not leave your tag tables with the default name, because it's just going to be a guesswork of what's inside that tag table. So that's the first tip I would like to give you. Now, when we open this tag table, you can see we have here everything from markers. These are system memory bits, clock memory bits. Then we have a bunch of inputs. We have outputs here. I mean, it's just a mix of everything. We have digital inputs, digital outputs, analog inputs, heating fans, cooling fans. It's all just thrown into one big tag table. I mean, that can definitely be cleaned up much better. We can make that much nicer. I think there's some markers here in the end as well, right? You have just some general markers here. Let's start, maybe let me have a look here. Let's start by creating first some groups here for the PLC tag. So we are going to, same as we did with the program blocks, we are going to segment these different inputs and outputs depending on the function. We're going to make a group for general PLC tags. We're going to make a group for process PLC tags, a group for motion, and a group for safety. So let's start with that. So I'm just taking over the same numbering as we did here with the program blocks. So 110 general, 130 process, 150 motion, and 170 safety. And what I'm going to do next is I'm going to split up the inputs from the outputs. I mean, it depends a little bit. If you have a smaller application, you don't need to do that maybe. But if you plan to work on making more complex and bigger applications down the line in the future, I would suggest you would make a clean cut between inputs and outputs. It will make it easier afterwards to find your data, to find out where your inputs are, where your outputs are. So here for general, I'm going to create both a new tag table called general inputs and one that's called general outputs right there. And I'm going to use this same type of structure with inputs and outputs for process, motion, and safety. I'm just going to start by copying them, and then I will rename them. That's the easiest. Just by the way, copying is just simply Control-C, Control-V in TIA Portal. So, I mean, try to use the keyboard shortcuts. They're very handy. Control-C, Control-V, that works perfect for these kind of things. Process, motion inputs, motion outputs, and then finally here, safety inputs and safety outputs. The next thing I'm going to do now is I'm going to move the IOs here from my default tag table here, from this huge table. I'm going to move them into these different tag tables. So I'll first start by kind of reorganizing them, inputs first, then outputs, and then the marker bits. The marker memory. So customer spare inputs, I will put that under general inputs. I mean, I don't know yet if they are going to be used for process. They are spare, so I'll just put them under general. Heating fan, cooling fan, shaker, those are all process inputs. So they go right here. Main cabinet power supply, servo power supply, those are general inputs. I mean, they apply to the application as a whole. They're not like process specific. Cooling fan, heater, vision status, shakers, vision push button. That's all process. Push buttons for the line, you know, to start the line, stop the line, to reset faults on your line, on your machine. Reset the safety. Those are general inputs, so we put them right there. Then we got some safety inputs, so those go under safety. Depositor, that's again process inputs. That's the depositor module process inputs. There we go. Other push buttons inputs. Safety, which by the way are easily recognizable by the yellow outline right here. So that's an easy way to spot the safety IOs. Inputs, weighing push button. So the weighing, that's part of the inspection module. So a process module. Again, some safety inputs, e-stops and guards, mold clean. That is part of the process module, the preparation of the mold, conditioning. So process. These are some homing sensors for motion, for an axis, for servo axis. So these go under motion inputs. There we go. Then we have some more guards, e-stops, safety inputs, vision. Again, process, that's inspection, reset faults, push buttons, general inputs. I hope you're starting to see how this works. So you just define in which module or in which tag table it belongs, and you just move it. Heater, that is process inputs. And we are almost through with the inputs, I think. The outputs are coming. It's a bit less, so that should go a bit faster. Safety inputs. Air supply, that's a general module, air supply. Cooling and weighing, again, those are process inputs. And finally, again, these are torques, ProfiSave, receive and send commands to access. I mean, the ProfiSave, that can be discussed if it goes under safety. Right now, I'll put them all under motion. There. And then now we have the outputs, depositor output, that's a process output, depositor module. These spare ones, the customer spare ones, I'll put them general. Safety outputs, STO, save torque off for frequency drives, and for servo modules, they go under safety outputs. Available analog outputs, general outputs, cooling and heating fans, vision commands, shaker, mold clean, that's all process. Another safety output. Vision, hammers, mold clean, that's all process, that belongs to specific process outputs. Push buttons, lamp push, so the lamp, the actual indication in the push button that you pressed it or that it's turned on, those are general outputs because they're for the start and the stop of the line. All right, almost there. Heater and cooler, process outputs. Air valves, that's safety outputs. Light beacon, that's the indication you can have on a line with different lights and a buzzer to show if a line is running, is faulted, is ready, maybe needs some product. That's the beacon, that's a general output. Mold clean, process, and weighing is process as well. And finally, the send the motion sent telegrams for the Profi safe. I'll put that under motion outputs. And that's it for the inputs and the outputs. You can see they're all, they all have some content in them, 31 here, 41. So yeah, we can close that now, makes it look a little bit more neat. I mean, you might think like, okay, do we really need these folders? I mean, I would say one thing you could do is just throw them all out here. You know, if you that's one click less to go to open this folder and then go to general process. So, I mean, sometimes I would just put them like this as well. But if you get, again, bigger structures, bigger applications, I would probably still prefer to have the group structure, and then underneath the group structure, you would have the tag tables. That makes everything just a little bit more neat, I would say. So what we have left now is some marker memory. What we have here at the top, this is system memory bits and clock memory bits right here. Marker 10, 0 until 10.7, and then marker 9. What I typically do is I'll make a separate tag table for that just to make it clear. So I'll call that system flags. There we go. And I'll throw these ones in here. I mean, and what I have left right now are some memory markers, some marker bits and marker bits, bytes, double words. And what I would recommend you is to get rid of these. I mean, in Semantic Manager, you know, the classic step 7, this was still appreciated and it was still used by many PLC programmers. But I mean, TIA portal is a different beast altogether. I mean, Siemens tells you it's not a good idea to keep marker memory in your PLC application. The main reasons being that they are hardware dependent, so not every PLC has the same range of marker memory. They are as well slower, so the performance marker memory is accessed, so the read and the write is accessed at a slower rate than global data, for example. And the third one, and that's actually the one that I think is the most important, is that you cannot structure marker memory. I mean, you can only use single data types, so you can use bools, int, reals. You cannot use a UDT in here. So for me, that's the biggest downside to marker memory. What we're going to do, except for this commissioning bit here, we're just going to delete all of these, and I'm going to show you afterwards what we're going to do instead. But for now, I'll delete these. And of course, if this would be an actual application I would work on, I would not just delete them without taking notes. I would write down or make a screenshot, put it in my log file, and I would write down, I deleted these, and remember to make structures out of these or to add these to global data, which is going to be the next point. So the one thing we have left now is the commissioning bit. And I'm going to do the same as with the system flags. I'm just going to add a new tag table called commissioning. Again, that makes it very clear if you're doing a commissioning and you made some bits. Again, I would not recommend making a marker bit. I would probably make a DB called DB commissioning and then put some bits in that DB. But if you plan to use a marker bit, just put it in its own tag table like this. And then it's very clear when you're in the software, okay, commissioning, and then you can look at the commissioning bit, you can do a cross-reference, see where it's used. I'm just quickly gonna go back to the inputs and the outputs. What I would like to show you before we're gonna go to the global data is I would like to show you how some inputs or outputs that belong together, how you can make a structure from that. So how you can actually make it more organized. And let's see which example I took here. Yeah, I mean, if we take the shaker, for example, let's just remove this one, the input words we're not going to need here. So let's just say a shaker, you see the communication is input word 960 and 962, the status words SW, and the process value, so the speed process value of the VFD, the status word of the VFD. These are right here defined as two separate input words. But what you can actually do in TIA Portal, and I'm going to show you that right now, is that you can create a UDT for this. So you can put both of these in one structure. So to do that, we first go to the PLC data type section right here. And we already seem to be having a frequency converter command and status. So the first word, input word here, which is probably the status word. Yeah, this is the status word. So these are all the status bits in the status word. This would be this input word right here, the first one. And what I'm going to do is I will rename this to UDT VFD status. And I'm not only going to put the status word in here, so not only this one, but I'm going to put as well the process value in here so that I have a structure with both of these input words in it. So the easiest way to do it, I can just insert a row here and put status word data type struct. So it's defined as a structure. And then I'll move all of these flags, these bits right here. So that's the status word. And then after that, I put, let's see, what was it called? Process value, exactly. So that's the VF, that's the actual speed. It's going to be a word, actual speed, word. There you go. And that would be the structure for the complete input area, the complete input area for one VFD communication. And what we do here then is, instead of having these two, I'm just going to replace this by one structure. So I could take this one, for example, UDT VFD status. It's not an input word. It needs to be defined. It turn into a pointer, but you can just open this and then accept it. See, now it accept, and you can see, okay, we still need to rename it. So let's just say VFD status. That under this, we have the status word at 960 and the actual speed at 962. That means this 962 we don't need anymore, because actually everything, the whole input communication, so everything that comes from the VFD now just comes directly into the status word. So that's another way to clean up inputs. We can do exactly the same for the output here. This would be the output word, the control word, which we find right here. Process output, control word, and the set point, or the set point speed. So 9. Okay, if we take the same one, 960 and 962. So we're just going to put those as well into one structure. Where were we here? Yeah. So UDT VFD command, not status, command. And what we're going to do here is we're going to create a control word like this, which is a structure as well. And we are going to add all these flags underneath. So that's the first part of the communication, of the command communication. And then we'll add the set point speed, which is a word. And that will be our command communication to the VFD. So if we now go back to our process outputs, to our tag table right here, it means that we can replace this word by the VFD command, UDT, the structure, the user-defined data type. We need to change this one to the pointer. So if we open this one now, you can see I have the control word at 960 and the set point speed at 962. That means here, 962, this one can be removed. And I can easily do it with this as well. So shaker 1, UDT VFD command. There we go. Then we've done it for both shakers, right? Like this. And we remove the set point here again. And on top of that, let's just call them command. So I hope you can see how this makes things more structured in your input and your output area. So instead of, I mean, this is like a small example with a shaker where you just have two words, where you had two words after each other. But imagine you have a communication I mean, there's VFDs or VFD communications that have more words, that have maybe 4 words. I think we have an example with a weighing cell. You see we have a communication with 3 different tags. So all of these three weighing tags, outputs, these outputs, you could as well just pour into an output structure, and then you can just replace these 3 lines with just one single line. And what's as well the good thing about this is that there's less chances of errors. If you have more VFDs, you just copy paste one and you give the start address, you point to the start address, and you don't have the same risk for making errors. You don't have to type in 3 different addresses. You just have to type in one address. So that makes it less prone to faulty programming. So you'll make less faults like that. I'm just going to do the same here for the shaker 1, because I'm going to use that a bit later for examples. So shaker 1 is UDT VFD status as well. And right here, we're going to point as well. So there you go. One last thing I'm going to touch on right here before we go on to the data itself, the global data, is renaming this. I mean, personally, I try to avoid using all capitals in my naming conventions. I can just give you an example of what I would do to make this more clear when it comes to naming the inputs and the outputs. What I normally do is I always start the name with the type of input. So for a digital input, I would write DI underscore. Then I would write the unit or the module. So to which unit or module does it belong? So in this case, a heating fan would be the heater module. Then the device, which would be the fan. And then the kind of equipment or the kind of, in this case, a local isolator, which type of switch. So then local isolator finally followed by the device tag. So the Q2, that would be a reference to the hardware drawings. You probably have a set of hardware drawings for your machine, and their Q2 would reference to the local isolator, the designation, the device tag in the hardware drawings. So yeah, the same here for the motor circuit breaker would be a heater fan, motor circuit breaker. Sometimes I would as well use an abbreviation like MCB. It depends a bit on the company you work for. Motor circuit breaker Q1. So that's for digital inputs. For analog inputs, I would just use, I mean, this may be a bad example because these are the VFDs, which we just converted here with a structure. But if we take, I think there's some temperatures as well somewhere. Let me have a look here. A heater temperature. So I would take an analog input to start with AI. Again, small heater, air. And then, for example, temperature inlet, B2, temperature outlet, B1. So you see, this kind of makes it easy. If you have to add these inputs or outputs to your program afterwards, you just start typing AI or DI, followed by the module, and TIA Portal it autofills. Normally that's standard enabled that you autofill your entry. So if you start typing AI, it will give you the possibilities, a list with possibilities of tags to choose from. So if you keep that kind of structure, then it will be easier to assign inputs and outputs to your application. Maybe I'll give you some example here. For example, for communication, I would typically use API. Yeah, which stands for Application Programming Interface. So I would use an API for a communication to a third-party equipment. For a VFD, you could start by putting VFD in front, VFD shaker, because it's a structure, it's not a DI or AI, it's a structure. So VFD shaker 2 status, VFD shaker 1 status. And outputs, it would be the same. It would be for digital, I would use DO, hammer 1, for example, on, followed by the device tag. An analog output would be AO, heater, again, first the module name, then the unit on the module, which would be heat. You could have a fan as well. If you had a fan, it would be fan, but this is the heating part of the heater. So heat on, for example, Q5, heat on Q3. That's it for the inputs and the outputs. So this was the first step, the cleaning up of the tag table right here, the PLC tags. So you see we have a nice structure now, general process, motion safety, with 2 tag tables for each, one for input, one for outputs. And we reorganized a little bit our system flags as well. They are in a separate system flag tag table and a bit for commissioning. So global data. So right here, this is from session 1, everything, all the DBs that we put under the data folder, the data group. So you can see there's an air supply DB, which is an instance database data block. And you can easily, I can show you how you can see that. You go to properties, and right here, you can see under type that it says instance DB. It belongs to the function block FB general air supply. So I can see it as well, that it's because it has the underscore DB at the end. That's kind of the standard TIA portal, the standard thing that TIA portal would probably give you as a default when you create an instance DB. Then you have some servo DBs. You've got depositor control, depositor servo, some HMI alarm commands. I mean, it's a lot of different blocks. Again, it's a little bit of a mess. There are 3 recipe DBs. Some safety instance DBs, SQL, and finally there are a couple of safety blocks right here. What I'm going to start with is I'm going to delete all the instance DBs just so we don't have such a large list of blocks. And the thing is that they are always going to be, I mean, when we later going to call the blocks in the actual, in the software, when you call the FBs, then these instance blocks will be generated again. And I'm going to show you how to do that then. But for now, we don't need them. So I'm just going to start by deleting everything that has an underscore DB in the end. Which is many blocks, as you can see. So we're going to end up with a nice little short list of blocks. So everything with underscore DB. Let me just check that I didn't forget anything or took one too many. DB, that looks good. Yeah. So those ones are gone. So you see our list is way smaller now. Yeah. And now, I mean, we have these 5 HMI blocks here. And, you know, for me, it seems they are going to be the blocks that communicate with the function blocks of this software. Because you have a setup. We can just go through them. A setup block. And here you can see there are some setup parameters for example, conveyor, maximum speed, acceleration, deceleration, jerk, depositor, max speed. There are some shaker minimum and maximum hertz, so minimum allowed hertz, maximum allowed hertz, cooling temperature, some scaling configuration. So basically this HMI setup block is a configuration block. Yeah, and that's going to be important for later. I'll show you how we're going to use that data. We have a status block, so that's probably gonna, yeah, that has the status of some units, shaker status, running at speed, faulted, cooling, running, faulted. So these are status I can see for both process modules like shakers and cooling, but as well there is some status bits from general modules like alarm, active, reset horn, air pressure. That's actually part of the air supply module. Some recipe status, an actual recipe number, name, etc. So those are status bits for the application. Setup we went. Command. They are, they're commands. Start the line, stop the line, the line speed, move forward, main conveyor forward. Buttons are in here. A command for air supply. So again, it's a mixed bag of commands that are being used for process-specific modules and for general modules. So basically, I hope you start seeing everything is all over the place here. So we have both process modules, general modules, all spread out over these 5 dBs. And I mean, maybe you're thinking, hey, at least here there's a separation between commands and status and setup. I'm here to tell you that, and I'm going to show you that there's a much better way of doing this. But let's first check these last 2 HMI blocks here. So we have parameters. That's probably going to be input fields on the HMI, entry fields for example, a shaker speed, an after runtime, a conveyor speed, cooling set point, some hammer times, probably to do with how it should hammer on the mold, a minimum air pressure, a vision recipe number. So these are parameters. And finally, there's an alarm HMI, which has, it has alarm triggers. You can see that by the fact that they're words. So because the HMI uses a word data type for triggering each bit in the word, or using each bit in the word for triggering a specific alarm on the HMI. So in this application, they have made a word trigger word for each equipment on the line, for shaker, cooler, as well for air supply network. Okay, so I opened these quickly just to show you that all our modules are divided over these 5 HMI blocks. And what I'm going to do is I'm going to show you a better way to organize this. So what we're going to start with, same as we just done with the library, same as we've done with the program blocks, is I'm going to start by making groups here again to create some kind of segmentation in the data. So I'll create the same groups as before, and I'm using 210 now to keep the same kind of numbering. You see for library we did 3, 10 for general, 10 general, process is 30, motion 50, safety is 70. So we're in the 200 range now. I'm doing 210 for general modules, 230 for process modules, 250 for motion related data, and finally 270 for safety. There we go. All right. So we created these groups right here, and now we're going to move the blocks to the correct groups. These HMI blocks, I'm just going to leave them here for now because we're gonna reorganize that. The servo, that is motion, so we'll move that to the motion area. Again, these blocks, they have a yellow outline, which means they're safety, so I'm moving them to the safety group. The recipe, that is that's part of the general module, and I mean you can see it right here just to show you. We had a recipe handling right here from the previous session, so that's as well a general data. And SQL for Siemens, that is actually still an underscore DB. So that was one instance DB that got lost in the deleting process. So, I mean, when I get software like this, I don't feel bad about deleting the instance DBs because they can be regenerated, and they don't hold, normally shouldn't hold important data. Global data, of course, you should not delete straight away. You should first have a plan on how to restructure it. So that's everything we had here organized under here. There's still, you can see there's still an empty process one here. We have nothing. And what we're going to do right now is we are going to make a specific DB for all the general modules, just 1 DB. And afterwards, we're going to do the same for the process. So let's start with that. And then afterwards, we're going to make the structures, and it will all get more clear then. So I'll start here by adding a new block under general, a data block called db general, like that. And I'm going to do the same right here under process. I'll just copy paste it. That goes easier. db process. So those are going to be the global data that contains the data for, on one side, the general modules, and on the other side, the process modules. I mean, at the moment, they're of course still empty. There's nothing in there, but we're going to change that right now. These blocks, these blocks, I know if I'm not really sure yet what I'm going to do with them, then I'll put them under a to-do folder. So I know that I still will have to have a look at them later. Makes it just a little bit more organized when you're working with an application that you don't have too many blocks just lying around. What we're going to do now is we're going to make a structure for, I'm going to show you how to make a template structure, a basic structure for a module. And then we're going to add those structures to the general DB and to the process DB. So to do that, we go to the PLC data type section right here. Yeah, and you see it's a little bit messy here as well. There's a lot of different data types, just put as, just a list of data types without any real structure. So what I'm first going to do here is I'm going to create, once again, the same group structure as we've done multiple times before. 110 general, 130 process, 150 motion, and 170 safety. And I'll put one last one, which is called vendor, because I see there are some data types there which are not by the programmer, but are by a vendor specific. So the vendor specific data types would be this SQL for Siemens interface. So I'll make a group here called SQL for Siemens. So this UDT goes here. So that's a UDT that was not created by the TIA programmer. That's a UDT that's been created by this company, SQL for Siemens. There is as well this SAI, which I know from working with this type of UDTs. This is from Mettler Toledo. So this is a weighing cell, a UDT for a weighing cell, or part of a control of a weighing cell. So we move that under here. So these UDTs are already in place. Now we're going to move the existing UDTs to the correct group. So upstream vision weighing unit, that's all process. Safety, can move that to the safety group right there. Downstream, that is as well process. OPC communication, that is general. There's one called unit here as well. I think it's process, I'm not sure. You would have to go inside and look. And finally, let me share. Okay, we have a couple of folders right here as well. Motion, all right. So there was a folder for motion. I'll just move these over here under motion. We delete this one. And we have some UDTs for a SQL database communications. So that would be, yeah, that would be under general. That's a general thing. And then we have UDT, VFD command, VFD status. Yeah, those are more like help functions. So I'll make a new group here called help UDTs, for example. And we put them right here together with the system flags. Okay, so now all our UDTs are PLC data types, as they're called here. They are grouped together. They're segmented. And what I'm going to do now, what I was mentioning before, is I'm going to make a template structure, one structure that we can use as a template for each module. All right, so for example, if we start here, if we have a look at our general modules, you can see we have air supply, alarm, conveyor. So I'm going to create a separate UDT for each of these general modules, and then I'm going to add them to the DB general right here. Afterwards, we're going to do the same for process. So if we take air supply as an example, it's called FB general air supply. So I will use the same naming. So under general, I'll first put all of these under to do. So we again clean up a little bit here. So general, add new data type. I always start with UDT because that's again user-defined data type. That's easy. Afterwards, if you want to add them as a data type, you just start typing UDT and then you get everything related to user-defined data types. And this one we're going to call general air supply. Yeah, just like that. And it automatically opens. And what I typically do, and this is, you can see this is well related to this, I will have a, for each module, I will have a config area as a struct. So this will be for configuration, for any configuration. Let's try to write that one correctly there. Configuration of the air supply module. That would be, that would be the same as the HMI setup. So you see right here in HMI setup, we have these three parameters here: air supply, scale, minimum, maximum, minimum, and time delay. So that would be probably what I would put here in the configuration. So now I just copied them to show you. So this would be an air supply. I'm just going to write it: air pressure scale. Okay, that was the max. A real, the min. I normally put the minimum first. That looks a little bit nicer. Minimum, maximum, and then air supply timeout delay. Air pressure timeout delay. Well, maybe it's better if I start like this. It's a time, so I'll put a small t in front here. Time, air pressure, timeout delay. So that would be the configuration area. Then I would have a button area. I mean, it depends a little bit. Sometimes I put the buttons under the command. Sometimes I make a separate structure for this. For now, I will show you how to have a dedicated button area. This would be all the buttons on the HMI related to the air supply. And if we look here at HMI command, you can see we had one button here for air supply. So we're going to put that here in our structure button. Let's call this air supply on, for example. Yeah. So that would be the button on the HMI to turn on your air supply. The next part of the structure would be parameters. And you can probably see where I'm going with this. Parameters. HMI parameters. So here we had a minimum air pressure, which would be a parameter from the screen, a real minimum air pressure. Minimum air pressure. Then I would have a command area, command structure. And I mean, for those of you who've already taken my courses, you probably recognize this from some of my material. So HMI command, the button we already used for the air supply. You see we had a command here for air supply on. So that would probably be a specific command, not used in the HMI, but like an internal command. air supply on, a status area, status. Now let's look if there's anything in the HMI status block for the air supply. Air pressure, okay. So the status from the air supply module that the air pressure is fine, that you can start your line, and that's a Boolean. And finally, a fault structure. By the way, you can see I like these small abbreviations. I mean, you can write them out, but I think these are generally accepted in the industry: command, status, fault, parameter, button, config. At least in the type of industries that I work in, these are generally accepted abbreviations. So finally, for the fault, we have the triggers. So for example, for the air supply, there's a word trigger here. I mean, we're just going to use that here, a word W trigger. So that would be the fault structure of our module structure. So what I've done now is all the air supply data, all the tags, the variables that were spread over these 5 different DBs, I've basically put them all together into one structure. And this structure I will put now into the general, the DB general. I'll go the official way because I think that's a bit easier to follow. Data general, so right here I would then put air supply, and the data type would be UDT general air supply. So you see, this is global data, so this means this is what we will use as communication between the different blocks in our application. And everything that has to do with air supply is now all modular. It's all containerized. It's all together in this block. So the configuration, the air pressure, the scaling of the air pressure sensor, the button from the HMI, the parameters from the HMI, the command, which is maybe used internally in the logic somewhere, and the status, the fault. It's all here in this block, and that just means it's much easier to troubleshoot. If you now need to troubleshoot the air supply system, you don't need to go and open 5 different blocks and look at things, look at data. You just need to open this one DB general, and you can look inside the structure. It's the same when you trace data, when you're going to record your data over time using a trace. It's much easier to add the different signals of the air supply if they're all within the same DB. You just have to start typing air supply dot and then config dot and then the parameter TIA portal autofills. So it's very easy just to add these things quickly to a trace and to troubleshoot, to debug any faults that you might have in the air supply system. Let's just do a couple more examples here with some of the other modules. So this is a template. So, I mean, I just added the specific tags for an air supply module. Of course, we would have to do that for each new module that we're creating. So I'm just creating 5 here, quickly copy paste. Air supply, let's see which other ones we have. I'm just going to take a couple here from the general. Alarm, conveyor, and line control. So alarm, conveyor, line control. And yeah, let's add a state handler as well. We had that as well in there. I'm not going to make all of them because then we're never going to fit everything into 1.5 hours. But okay, so I'll just take these 5 ones as an example and I just add them here then. Alarm, conveyor, yeah, that was almost correct. UDT general conveyor, line control, I'll just type it like this. State handler. So you just fill this up with all the modules that you have. I mean, I just took these 5 as an example. Now that we have made this DB general, I'll quickly give you an example of how you actually use it into your logic. So this is a general module. So air supply, for example, let's take that one as an example. So under FC general modules, you would call the air supply module. So I just pull it over here. I'm not going to do the instances yet. That's going to come later. So this would be my air supply, my function block. And then I would simply add this structure that we just created. I would just add that to the in-out air supply. And I would use the same UDT that I just created, UDT general air supply. And then you can see you have your whole structure right here available. I mean, the advantages of using the in-out is that you are calling it by reference, not by value, which means it saves on system resources, basically. Lately, I'm thinking more about this, but I mean, an in-out is smart and saves resources, but the big disadvantage of using an in-out is that it's difficult to troubleshoot, because you cannot, if you use one of these tags right here in the logic and it's used somewhere else in your logic, it cannot cross-reference through the in-out in TIA portal anyway. That's a disadvantage. So another way of doing it is putting all the necessary signals as inputs and outputs. You would use more system resources, but you will it will help you with troubleshooting, but actually finding your data when you do a cross-reference. So we've added to the in-out, so we need to update our block call. And then right here, you see that's the new structure that I've added. And right here, I would just then add the DB general air supply structure, just like that. And right now, you can have logic in this air supply that uses the configuration that writes to the status in your module structure. It reads the parameters from your structure. You know, this structure would also be tagged up in your HMI. By the way, you can do that as one full structure, so just one tag that you need to add to the complete structure. That's another advantage. So you don't need to, in your HMI, you don't need to put a separate tag for each of these individual tags. You just add the complete structure as one thing in the HMI. So parameters, buttons from the HMI, that comes straight into the block. It's like a gateway, so the block read and writes to the structure. And if you need to use this air supply somewhere else, for example, the air pressure OK signal, right here you have, we define the status bit right here for air pressure OK. Then you can just add that somewhere else. For example, I'm just going to give a quick example here. If you would have a conveyor and you would need an air pressure OK signal here, then you can just add an input right here. Or air supply. Okay, I can't remember which one I was. But let's say you need to use that right here. Air pressure, okay. DB gen, then you add the specific status, air pressure, okay, from this module, from the modular structure. So that's how you communicate data between the blocks using these modules. So we've done this now for the general modules. Yeah, what I can still show you is how to use the configuration. So it has a configuration area, this module. So what I typically do is I'll have a configuration block, which I call in a first scan cycle, for example, which is part of the general modules. And then you can do, for example, you can type configuration air supply. And then we just use the configuration structure from the air supply, the minimum scale from the air pressure, for example, 0 bar. And you can see I like to use SCL or like a written text for this, because assigning parameters is easier like this. You just make a list of parameters like that. It's easier than, for example, ladder logic or function block. So just for a list of assigning values to parameters, I would suggest using SCL because it's easy to read. Maximum pressure scaling, 6 bar. So this is, for example, how you can use a configuration function like this to configure each module. So now I've made the modules for general. Now we're going to do the same for the process modules. What I'm going to do here is I'm not going to define, here I defined a UDT for each module. Here I'm going to do it a little bit different. I'm going to define a UDT for each unit. The reason I'm going to do that, not per module, is because a process module is a little bit bigger. It has a little bit more blocks than a general module. Just an air supply module just has the air supply. But for example, the settling module, that's to get the product to the corners of the cavities, by using a shaker, for example. You might have more than one shaker in this. You might have 3, 4, 5 shakers. So what I like to do here is to actually make a UDT for the unit, for the shaker, and then call this shaker 5 times in the module. I mean, it will get more clear in a second. So I can show you right here. Let's start by that. Here as well, these ones I'm going to put in a to-do group so they don't fill the screen. They don't, so it's easier to see. So I'll copy the air supply. I'll call this one process shaker, for example. Yeah. And then I'm not gonna, it will always have the same structure. I would need to have a look in these DBs again, right here, in these HMI DBs to see which specific things are shaker related. But so I would make a process for a shaker, a depositor, what else? A heating fan, a cooling fan, for example. Heating fan, cooling fan. You might have, for example, a water system for a depositor system to make sure the water system gets to a certain temperature. Those are just units, some process units. And so I have not created a UDT for the module itself, but what I'm going to do now is in the data block of process, I'm going to create a structure for all of these process modules. So upstream, I will have a structure. I'll just put spare for now. Like this. I'll just quickly put them up here. Conditioning, depositing, settling, cooling, inspection, demolding, and downstream. And then underneath here, I would put these data structure which I just generated, which I just created right here. For example, settling, I would have shaker 1, UDT, process, shaker, and I would have a second shaker, shaker 2. For depositing, for example, you would have a depositor, UDT process depositor, and a water system. water system. Process water system. Okay, so I hope you can see the thought behind this. The idea is that these units, they can be used in different modules. You know, maybe your molding line would have different settling areas. It would have 2 depositors, for example. So by this, you're using these unit structures right here as Lego blocks, as if in a way to build. So each module, each process module, you can build out of different units. I think that's the way I do it because I work in general with bigger projects. Of course, if your process module is just one single piece of equipment, then I would probably do the same as with the general modules. I just would make a UDT for the module instead of a UDT for a unit in the module. But again, if you think about doing bigger projects in the future, then you're probably going to have modules that consist of different equipment within one module. And then this is probably the way to go. And I mean, one of the other reasons that I've structured it like that is because the function blocks, the reusable function blocks that we use for process, for example, in the library are typically as well made for a unit. So for example, you will find a shaker in here, you will find a depositor. So each one of these structures would fit for a function call of a shaker, for example, or a depositor. If we now, for example, if we give an example here for the settling for the shakers, if I, for example, have 2 shaker calls in here, let's just drag them from here, shaker 1, shaker 2 right here. Then I can do the same as before with the air supply. I can make an in-out area right here, where I use the UDT process shaker. And now I'm going to add the module data to it. Let's first update these ones. DB process settling shaker 1 and shaker 2. So see, so this is the reason that I've segmented them like this. The problem is if you would have done it as a whole module, then you could have not. Then you have to put kind of the UDT of the whole module on the single shaker block, and then how to decide if you're using data for shaker 1 or for data 2. So segmentation per unit, and then each module you just fill with the correct units for that module, just like here. So it's a little bit different than with the general modules. Yeah, that's it for the global data. But now I'm going to do the final part on the instance data, and that's going to be very interesting as well, because I'm going to make some distinctions between when to use multi-instances versus when to use single instances. So, I mean, basically there is a difference between calling blocks in an FC or an FB that's only used one time in an application. Like, for example, process modules, or right here, general modules. This FC is just used one time in the application, the FC process modules as well. And there's a difference between calling blocks in a library function, in a function that's been called or that can be called multiple times. For example, if we go to the library, for example, in the shaker. A shaker, as you've seen just before in my example, we called it 2 times already. So there's a difference which type of instance you use. And first, I will start with the blocks that are only called one time in the application. For example, FC general modules. Yeah, so what I'm going to start, I mean, this is an FC. I'm going to use exactly the same, but I'm going to create it as an FB because we're going to show you something with a multi-instance, and that requires an FB. So I'm going to make exactly the same function here, just FB general modules, which is a function block. All right. So this is basically the same as this. I'm just doing it as an example. And what I'm going to do now is I'll just call the first 4 modules right here with a multi-instance. And I'm going to show you how you do that. I'm going to show you what the disadvantage is of that. So right here, I'm not changing the name right now. I'm just quickly calling them to make this example. So air supply, alarm, conveyor, all defined as multi-instance. Here you can choose single instance, multi-instance, and parameter instance. Multi-instance, line control right here, multi-instance. So 4 blocks have been called right here, and they've all been called with a multi-instance. And what multi-instance means is that the data, the instance belonging to this block, which is input, output, in, out, and static data. If we have a look quickly, it's this data right here, input, output, in, out, and static. That will be part of your instance. Temp is not part of that. This data is now part of the static area of the parent block, which is in this case the FB general modules. So that's the meaning of multi-instance, means it has been instantiated under the parent block. And now if we call this FB general modules in the OB1 right here, so I'll just delete this one and I'll call this one instead. I need to define a single instance as well. Cannot use a multi-instance here because an OB does not have a static area. So now we have, I'll put them here, we have the block call and the instance data of general modules right here. So this instance DB, if I open it, it contains these 4 multi-instances which I just created. So all 4 instances, so air supply, alarm, conveyor, line control, are under this block. Now, if I make a change, if I go back here, what I want to show you now is that if you make a change, for example, in one block, air supply, for example, right here, I'll just add air supply, air fault. I'll just add some quick example static bit here. So because I added a static, that's going to change the instance, which you can see right here. The instance is red. So you would think it only affected the air supply instance. So if you would download this, it would then reinitialize the data in that block. But if we have a look at the OB1 right now, you can see that this DB, so the parent instance DB, which has all 4 block calls, it needs to be regenerated as well. It needs to be updated. So by doing, if you would download this now, it would recompile, it would update the parent instance. And that would mean that not only the instance data of the air supply block will be reinitialized to, so the values could be back to the initial values, but as well, you are going to initialize the alarm block, the conveyor block, and the line control block. So this is a little bit, this can be an issue. I mean, this is something you need to think about when you do a lot of work online, when you do a lot of edits on a running production machine, because it's kind of risky to make a change, one small change in an air supply, but as well affect the alarm block, the conveyor block, and the line control block. And as I mentioned, that you affect it because the parent instance holds all 4 instances. So if you change one of these, all of these instances will be reinitialized, the data. Now, the second way that you can do this, and I'll show you this right now, which we can do in the FC because we're going to use single instance now. So I'll delete these ones again. And this one we're going to call again in a sec. So if I now do the same under an FC, and this is the reason I'm using an FC here. if we call those same blocks and we use single instances instead, alarm, conveyor, so I all call them with a single instance. Multi-instance, by the way, is not possible here since I'm using an FC. So I'm using a single instance. So you can see I have these 4 single instances. If I now make a small change in air supply in the block interface, so static, for example, I'll put air OK. And just before I change this, I want to show you this. I'll call this FC in the OB1. So there's no instance data connected to this. So the instance data of this air supply block needs to be compiled. So you would do that by compiling the application. I'm not going to do that now, but if you compile this, then only this instance DB will be initialized. And because these ones have all been created as single instance DBs, you will not affect the instance data of these blocks. So this is what I normally do if you're calling blocks into a function that is not being used other places, just one place. I would suggest you call them with an instance DB because it is more safe when you do edits online, when you make changes during production. And the disadvantage is that you will have all these blocks here, but what I then typically do to make this neat and organized is I create a new group called instances. And you just tuck all of these instance DBs right here. And you close this and you never need to look at that anymore because they're just instance DBs. It's not something you go to very often. I mean, actually, you never actually need to go in there anymore once you call them. And once again, your application is neat and organized. So I used instances. You have more blocks, but they are nicely tucked underneath here. By using this, you don't have the risk of initializing other data when you're doing some online edits. So this was to show you the difference between when to use multi-instances, that you can use multi-instances, but that it's maybe a better idea to use single instances when you're calling blocks in an FC or an FB that's only been used one time in your application. That's basically it for the instance data. I just want to give you one final tip here, and that is that instance data should never be used outside of the block you're calling it together with, because then you kind of lose modularity in your application. Instance data is just there to contain the data that you use inside that block. So I would strongly suggest you do not use tags from an instance database somewhere else in your logic. For interchange of data between FBs and FCs, just use global data. Use the modular approach that I showed you with the global data, creating the modules for the general modules, the process modules. Update those modules with the data you need if there's some data missing, but then use purely global data to communicate between the different segments, the different program parts of your application. And if you're just about to get started with your first TIA Portal project, or you simply want to get better at structuring PLC applications, then don't forget to grab my free guide. You can download the guide by simply clicking on the link in the description below this video. There's no better time than now to start your TIA Portal journey.